Hello everyone, welcome to my class. In today's class, we are going to solve previous year questions from the chapter Real Numbers, and then we will also solve some competency based questions. So let's see. Prove that root 3 is an irrational number. So this question has been asked in Standard Paper 2023, Basic 2020, as well as this was included in the Sample Paper 2023. So we get many questions like this. Prove root 5 is irrational, prove root 2 is irrational, prove root 11 is irrational, as well as root 7 is irrational. Even you get this in fraction form, addition form. So let's see how to solve it now. So the main concept here is we solve it on the basis of contradiction. First we assume this is rational number. When this is rational number, we say that it is a upon b or b upon q, whatever you can assume, and then we say that these are the co-prime numbers, so they don't have any common factor other than 1. But we will prove that a and b or whatever is the rational number, it will have some common factor. So on the basis of contradiction, we prove that this is irrational number. So let's see how to do this. So assume root 3 is rational number. So if root 3 is irrational number, then there we can write root 3 is equal to a over b, where a and b are co-primes. Co-prime means the common factors are, they don't have any common factor actually other than 1. So their common factor is just 1. Now you see that we have taken root 3 is equal to a over b. Now we will square both the sides. Square both sides, and then you get root 3 whole square equals a over b whole square. So that is equal to 3 is equal to a square upon b square. So this means that 3, now we can write this as like this: 3b square equals a square, right? So 3b square is equal to a square means 3 divides a square, right? So we write 3 divides a square. Since 3 divides a square, so we can also say that 3 divides a, 3 divides a. So by the theorem, if any real number p divides a square, then p also divides a. Okay, so we can write 3 divides a. So you can say that 3 is factor of a. So we got one factor of a, that is 3. 3 is factor of a. Now you see that, now let's assume another value of a. Let a is equal to 3c. Okay, now we will square it. So you will get a square equals 3c whole squared, which is nothing but 9c square. But we already have the value of a square, that is 3b square. So this I will replace. 3b square equals, we can write 9c square. Yeah, 9c square we can write. So see, both the sides we can divide it by 3, and we get here b square equals 3c square. Now this implies that 3 divides b square. 3 divides b square. Since 3 divides b square, therefore 3 also divides b. Okay, so we can say that 3 is factor of b, right? So we can say that 3 is factor of b. Let me mark this one as 1 and this one as 2. See, now we got 3 as factor of a and 3 as factor of b. But what we have assumed? We have assumed that a and b are co-prime because root 3 is a rational number. So co-prime means they should not have any common factor other than 1. But here we got 3 as the common factor. So from 1 and 2, 3 is common factor of A and B. Okay, so our assumption is wrong because 3 is the common factor. So this contradicts the fact that A and B are co-prime. This contradicts that AB are co-prime. So this means our assumption is not correct. Therefore, our assumption is not correct. Hence, root 3 is irrational. So I hope this is easy and clearly understood to everyone. Yeah. Now let's see the next question. So next question is, this question came in basic paper 2024. So this is the recent question paper. Now prove that -7 minus 2 root 3 is an irrational number given that root 3 is an irrational number. So this is very good point already given to you here. We have to prove that -7 minus 2 root 3 is an irrational number, and we are given root 3 is an irrational number. So how we are going to prove this? Since it is already given root 3 is an irrational number, so we will make root 3 the subject, like we will write it like this. We will get the equation here, and then this is given already root 3 is irrational, so whatever is equal to root 3, that will also be irrational. So this is the method we are going to follow here. Now see how do we do that. So assume that, so same assumption we will do. Assume that -7 minus 2 root 3 is rational number. If this is a rational number, then there exists A over B, where A and B are co-prime. Means they have common factor as 1. Okay, now, so let's make root 3 the subject. So we transpose it. Hence, minus 2 root 3 equals A over B plus 7. And then you can have it like this. Root 3 equals minus 1 over 2 A over B plus 7. Right. Now see, here root 3 is equal to minus 1 over 2 A upon B plus 7. Now we have assumed that A over B is rational number, but here it is given root 3 is irrational. Here it is already given. Okay, so since it is given root 3 is irrational, therefore therefore one moment, we can say -7 minus 2 root 3 is also irrational. Easy. So any question of this kind comes, you can solve it in this way. This is easier ones. Now let's see the next question. Check whether 6 to the power of n can end with the digit 0 for any natural number n. Yeah, so this question has come many times. Standard paper 2010, 2011, 2012 and 2023. This is repeated many times. Okay, so So I guess you know already, for any number to end with digit 0, it should have factors 2 and 5. Okay, so based on that concept, we are going to solve this. Okay, now since to end with 0, a number should have 2 and 5 as their factors. So this is very important point to remember. Okay, now we will factorize 6 to the power of n. So when we factorize 6 to the power of n, we will write it as 2 times 3 to the power of n, which is nothing but 2 to the power of n times 3 to the power of n. Okay, so there is no 5. We can only find 2 here. There is no 5. So by fundamental theorem of arithmetic, so So we can say that, or fundamental theorem of arithmetic, it guarantees that uh, there cannot be in any other, there can't be any other prime factors of 6 to the power of n. So for 6 to the power of n, there is no natural number for which 6 to the power of end with digit 0. So you can write therefore for 6 to the power of n, there is no natural number for which 6 to the power of n end with digit 0. Oh, so I have seen in many papers there are many questions like this. You can also have a question like 6 to the power of n, 12 6 to the power of n we did now, so 4 to the power of n, then 12 to the power of n. So this is the same method you have to use every time. Now the next question is, find the least number that is divisible by all the numbers from 1 to 10, both inclusive. So this is competency based question. Okay, now understand it this way. The question is asking the least number that is divisible by. So you have to find a number which is divisible by all the numbers from 1 to 10, including 1 to 10. Okay, so whatever answer we are going to get has to be bigger than this, bigger than 1 to 10, because that number has to be divided by 1 to 10. Okay, so whenever you have this kind of question, you have to find the LCM of numbers from 1 to 10. So this is going to be very big. Okay, so let's do. So the first step is find LCM of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so let's do this. I'll do it this way all together, everything all together once. So, because this will keep my work easier. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now let's do with 2. Okay, now we can do again with 2. 2, 9, and 5. Okay, no chance of doing with 2, so let's go with 3 now. So we have 1 here, 1 here, this becomes 1, this is 1, 5 comes down, this is 1, 7 comes down, 2 is there, 3 we will get here, and this comes down. Okay, now we cannot do with 3 as well, so let's take 5 now. 5. 1, 1, 1, 1, 1, 1, 7, 2, 3, and 1. Okay, now let's see what is LCM. LCM of the numbers 1 to 10. So this will be 2 times 2 times 3 times 5 times 7 times 2 times 3. Okay, so let's do this quickly. 2 twos 4, 4 twos 8, and 8 fives is 40. 40 into 3 is 120. 120, this will be 360, and then 360 into 7 will give you 2520. So this is the answer. So 2520 is the number which is divisible by all the numbers from 1 to 10. I hope this is clear to everyone. Let's go to the next one. Okay, so this question has come in standard paper 2024. Now let's see the question. The smallest irrational number by which root 20 should be multiplied so as to get a rational number. Okay, so we have to look for the smallest irrational number. That number has to be multiplied with root 20 and the result will be a rational number. Okay, we can multiply with each of these and see which answer is satisfying for this condition. So root 2 into root 20, that is nothing but 2 times this 20 can be written as 2 times 2 times 5. Hence you get here 2 root 10. So this is irrational number, right? So this doesn't stand true for our answer. Then we do root 20 times root 20, and we are getting here 20. This is rational number, but let's check others also. Now you have 5 times root 20. That will give you 5 root 20. And this doesn't stand true on the given condition because this is also irrational number. Now we will multiply root 20 with root 5. So see, when you multiply this, you get root 100, which is nothing but 10, and again this is a rational number. So we got rational number in two options, but your question is the smallest irrational number by which 20 should be multiplied. So our answer will be root 5. So root 5 is the smallest irrational number by which we multiply root 20 to get a rational number. Now, the next question is, so this question has come in standard paper 2024. If a is equal to 2 to the power of 2 times 3 to the power of n, b equals 2 to the power of 2 times 3 times 5, c equals 2 to the power of 2 times 3 times 7, if ABC is, I guess this was if LCM of ABC. This question was if LCM of ABC is 3780, then n is. So what is the value of n out of 1, 2, 3, and 0? Okay, so what is given here? LCM of ABC is 3780. Okay, now we have the values of A, 2 to the power of 2 into 3 to the power of n. B is 2 squared times 3 times 5, and C is 2 squared times 3 times 7. Okay, let me write LCM of ABC from here. So LCM of ABC will be 2 squared times, so we have 3 here, and we don't know the power of this 3. So we take this 3 to the power of n times 3, and then times, we will write 5, and then we write 7. This is important step, very important. If you do mistake here, yeah, you will do it wrong. Now see, this is our LCM, and here is the value of the LCM, so we can equate it. So we will write it this way: is equal to 3780, because this is LCM of ABC and this is LCM of ABC. We can equate them. Now to get the value of n, we just transpose everything this side. So 3 to the power of n equals 3780 over, so 2 square can be written as 4 times 3 times 5 times 7. Now we can cancel them. So it will be, so you can have this like 4 nines 36, 4 4 16, 4 5 20, and then 3 threes 9, 3 ones 3, 3 fives 15, and 5 5 6 30, and 5 threes 15, and then we get 7 nines is 63. So we got 3 to the power of n equals 9. So how we will solve it further? This is 9, we will write this as base 3. So you will write 3 to the power of n equals 3 square. Since the bases are same, so we will say n is equal to 2. Hence our answer is 2. So this is the answer. I hope this is clear. Answer is n is equal to 2. Let's move to the next one. Now this is competency based question. So the HCF of P and 93 is 31. Okay. So it says HCF of P and 93 is 31, where P is a natural number. Which of these can be true for value of P? Okay, when it says that 31 is HCF of P and 93, it means that 31 is factor of P and 93, correct? Yeah. So which of these will be true here? Hmm? First, P is multiple of 31, right? P is multiple of 31, that's why 31 is factor of P. And then P is multiple of 93, we can't say that because it can be smaller than 93. Then P is an even number? No, we cannot say that. Okay, most probably we can say P is an odd number. Okay, so these two stands true. P is multiple of 31 and P is an odd number. Yeah, let's go to the next one. So here both the options are true, A and B, A and B. Now the next one is, if two positive integers a and b are written as a equals x cube y square, a equals x cube y square, b equals xy cube, where xy are prime numbers. Xy are prime numbers, then the result obtained by dividing the product of the positive integers by the LCM AB is, okay. So what it says that mm, x, y are prime numbers. Then the result obtained by dividing. Okay, okay. So let's see. how to work on this. So first we will find the product of the positive integers. So it will be AB equals x to the power of 3y square times xy cubed, and that will give you x to the power of 4 y to the power of 5. Now it says that result obtained by dividing the product of positive integers by the LCM of AB. So what will be the LCM of AB? LCM of AB. So when we have to write the LCM, so we have to take the largest factor, right? So here the this one we will take from x cube and x, we will take x cube, and from here y square and y cube we will take y cube. So your LCM is x cubed y cubed. Okay. Now the next part is the result. X, Y are prime numbers. Then the result obtained by dividing the product. You have to divide the product by the LCM. So our product is x to the power of 4, y to the power of 5, and we divide this by x cube, y cube. So you get here x, y squared. So this is the answer. I hope this is clear to everyone. Now, so this is another a general type of question where many students do mistake. So it's better to know. The ratio of the two numbers is 15 is to 11. So here ratios of the numbers are given and their HCF is 13. Find the numbers. So let the numbers be 15x and 11x. Okay. So when I assumed my numbers are 15x and 11x, then their HCF will be, see here they have given HCF is 13. Let's work here. It will be 15x, 11x, and x is the common. So you get the HCF as x. So it says that value of x is 13 because we got the HCF x and here it is given the HCF is 13. So x is 13. So our numbers are 15x, that is 15 times 13, and another number will be 11 times 13. So this you can multiply. 11x is equal to 11 times 13. So we multiply this and we get 190. This thing 195, and then this one will be 13 ones 13 143. So our answer will be, find the numbers. Answer is the numbers are 195 and 143. Easier. Now, yeah, this one is a bit lengthy. Let's see how to work on this. The sum of two numbers is 528 and their HCF is 33. Okay, this is important to know. This is also important. Then find the number of pairs satisfying the upper condition. This is your competency type question. Okay. Now it says that the sum of the numbers is 528 and their HCF is 33. Okay. Since HCF is given as 33, it means whatever are the numbers, those numbers are multiples of 33. That's why the common factor is 33. Okay, let's take the number as 33x and 33y. We will take it like this. So one number is 33x and another number is 33y. Now here this is given already. The sum of the two numbers is 528. So we can write this as 33x plus 33y equals 528. Now, yeah, we can get some common factors here. So we can divide. Okay. Hmm. So let's see if 528 is divisible by 33 or not. So you get here 12, 3, 9, 1, 8. Okay, 6. Yeah, good. So we can divide it. Yeah. So let's divide throughout by 33 and you get x plus y equals 16. So it says sum of two numbers is 528, their HCF is 33, then find the number of pairs satisfying the above condition. So we will write the number pair as the sum of x and y, which gives you 16. So what are the number pairs that will give you 16 as the sum? So the number pairs that give us 16 as the sum is, say, 1 and 15. 1 plus 15 will give you 16. Another number pair. So just keep on increasing first value. So 2 and 14. And then 3 and 13. How many actually they are asking? Okay. So find the number of pairs satisfying. Okay. So we can have then after 3, we can write 4 and 12. Yes. And then we can write 5 and 11. One second. Okay, so we should get the sum as 16. Okay, so we can write so many. So we just stop with this few because now you can also write 6, 10, and then we can also have 7, 9. We can have so many. Hmm. So we will go with this one. So your required numbers will be, so 1 and 15. So if you take 1 and 15, since this is the HCF is 13, so it will be 1 into 33, and then you will have 15 times 33, right? So this will be your one number, so it will be 33, and just multiply and you will get something. So that is 33 times 15. 15 3 is 45, 4 15 3 is 45, and then you get 495. Like this we can form many number pairs. Okay, so I hope this is clear to everyone. Yeah. Now let's see the another question. So here, this is again competency based question. A forester wants to plant 66 mango trees, 88 orange trees, and 110 apple trees in equal rows. Also, he wants to make distinct rows of tree, that is only one type of trees in one row. Find the minimum number of rows. Okay. So here there is equal distribution. You are finding equal number of rows, then minimum number of rows. All these are indications of finding the HCF. So we will find HCF of 66, 88 and 110. So we can write 66 as 2 times 3 times 11, 88 as 2 times 2 times 2 times 11, and then 110 is nothing but 2 times 5 times 11. Okay, so you can see that the common factors, the HCF will be this 2 and this 11, because we have 11 in all three groups. So your HCF will be 2 times 11. It means we are going to have 22 rows. Okay, now we will find the number of rows for each kind of, like for mango, for orange, and for apple. So we can find required number of rows. So it is 66 over 22 plus 88 over 22 plus 110 over 22. So this will give you 3 plus 4 plus, and this one will be 5. And that gives you 12. So hence, answer is 12. So this is one competency based question. Find the minimum number of rows. So we are going to have minimum number of rows as 12. I hope this is clear to everyone. Now we go to the next question. I guess this is the last one now. An orchid has two rectangular fields of the same width but different lengths. So the fields are same width, means same width, but the lengths are different. Now they are required to plant 84 trees in the smaller field and 231 trees in the larger field. In both the fields, the trees will be planted in the same number of rows. Okay, that can be planted in this arrangement. Again, we have to see the number of rows. What is the most number of rows that can be planted in this arrangement? If the trees are planted in the number of rows obtained in part A, how many columns will each field have? So this is very simple. We have to find this number of rows, we are going to find the HCF of 84 and 231. So HCF of 84 and 231. So how can we do this? How can we do this? Okay, so 84 2 times, let me write it here, factorize it here. 242, 221, 3777. And then you get 2 times 2 times 3 times 7, and then 231. 231 moment. We can write it. Yeah. And then for 231, so this is divisible by 3. 3 sevens is 21, 3 sevens is 21, and then 7, 11, and 11 this thing. So you get here 3 times 7 times 11. Okay, so your HCF is 3 times 3 is common here and 7 is common here. So we get the HCF as 21. Okay, so now the next part of the question is, if the trees are planted in the number of rows obtained in part A, how many columns will each field have? So, so number of columns for, first we will find for the smaller one, smaller field. Obviously we are going to divide it. So it is 84 divided by 21. 84 divided by 21. So 4 ones 4 and 4 twos 8. So that will give you 4. And then for the larger field, it will be 231 divided by 21. And that will be 11. So I hope this is clear to everyone. So we don't have many more things apart from proving irrationality of the numbers. Then questions based on LCM and HCF and fundamental theorem of arithmetic prove that this digit can end with 0. So these are few things which is generally asked, and this chapter is of 6 marks. So I have covered most of the things. So if anything is there, you can comment and ask me. Thank you for joining.